Hello, I welcome you all to this another interesting screencast. And the problem reads: the rod is supported by smooth journal bearings at A, B, and C, and is subjected to the two forces, force 400 and 600. Determine the reactions at these supports. This problem is coming from the Engineering Mechanics and Statics textbook, 13th edition by R.C. Hibbeler. So let me make mention of something about the journal bearing, smooth journal bearing. So let me draw one and then just make mention because I did receive a question from one of the people that the students that watch or the supporters, students that watch. So let's say this is you have something like so, which goes out there like so. Okay, so imagine you have a journal bearing like so. There we go. All right, so and then this is your rod. All right, so let's say this is your axis, which is x, and then you have this is your z. All right, so ideally, if you only have a single support like this, you are going to have, if this point, let's say it is A, you are going to have here a reaction force. So let me just remove these V's, I mean these are sharp ends. I just say this is my Z axis positive and this is my X axis positive. Alright, so ideally, if I was to write reactions for just a single bearing like this and the member through it, this member here, this rod is free to move in this direction, okay, in this direction. If this was the Z axis, so let's say this is the Z axis, I mean the Y axis. So it is free to move in the Y axis, right? We will not have any reaction there like so, okay? But we'll have a reaction in the X axis, all right? In the Z axis. Then we'll have also moments about the Z axis. So I'll draw the moments using two arrows like so, okay? We'll have these couple reactions or moment reactions in the x-axis. Okay, this rod will have or this support will resist a moment, or it will cause a reaction of a moment in the x-axis as well. As so I'll call this as mz, and then this one mz, yes, mz, then this one as mx. So we'll have these moments for a single support. But if you have a body, that is supported elsewhere, all right, the same body, if it has other supports elsewhere, then you don't apply these moments, okay? You don't apply these moments, all right? You don't apply these moments, all right? You neglect them because even if you apply them, they'll still give you a zero. But you will have a work that will be so much complicated and it will take you too much time to work on. So you find in your textbooks, okay, in literature, they will tell you to say neglect the couple moments for these supports if the body is supported elsewhere. So I wanted to make mention of this, okay? So neglect the couple moments at this kind of support, like in here we are talking about the journal bearing. Neglect them, don't apply them. If the body, if the structure, okay, is supported elsewhere, then you can neglect those, all right? There's really no need to consider them. Just consider the translational reaction forces, which is this AX and AZ, okay? Is that fine? So I just wanted to make mention of this, okay, because I had a question about one of these problems, so I thought of just I'm mentioning it in this before I even start solving. All right. So neglect the couple moments, neglect these reaction forces if the body or the frame or a structure is supported elsewhere. All right, because they will still give you zeros even if you include it, but you will make your problem even more complicated because you will have a lot of unknowns which you don't even necessarily need. Okay. I hope I've driven the point home. So let's draw the free body diagram then. Okay. At A, we expect a reaction force AZ, and then in this direction, you expect AX. And then at B, we expect another reaction there. We expect a reaction here of BZ, and then this side you expect BX. Then here you expect a reaction in this direction like this, which is CX, and then you expect another reaction in this direction, which is CY. All right, so you have all those reactions that I've just indicated. Okay, this is AX. You have all those reactions. So now what we're going to do is again to apply the equations of equilibrium. Okay, so this is a 3D again rigid body equilibrium problem. So how many equations of equilibrium do we have? 6. How many unknowns do we have? 1, 2, 3, 4, 5, 6. We have 6 unknowns. But of course, I should think some of them are equal to 0, right? Maybe, I don't know. Let's do the work. So let's start with summation of forces in the x direction like so. What do we have in the x? We seem to have a lot. We have ax plus bx plus cx. What else? That's all, right? Equal to 0. All right, and then summation of forces in the y direction. So let me just put this equation just in front of, I put it here like so, okay, because the equations seem to be a lot, so that I reserve space. So summation of forces in the y, what do we have in the y? We have cy plus 400. Anything else in that direction? Seems promising, this one. Great. So this one, it means we can find our cy. Oh, great. So our cy therefore will be equal to minus 400 newtons. Great. Then let's go for summation of forces in the z direction. What do we have? We have az. What else? We have BZ. What else? We have plus 600. What else? These are the only ones that we have, right? So this is equal to 0. Okay. So now let's start doing the moments, right? So we have summation of moments about the x-axis equal to 0. About the x-axis, of course, ax and ay, I mean ax and az do not participate, but bz will participate, 600 will participate, and which other one? Cy will participate, right? So let's do that. So this one you tend to, again, using your thumb rule, your right hand thumb rule, okay, to denote the direction of your moment. BZ will tend to rotate or it will tend to cause a moment about the x-axis in the positive direction. So we'll have BZ times the lever arm, which is just 0.6. Okay. And then 600 also, it will cause a positive moment. All right, a positive moment. So this one will be equal to plus 600 times 1.2. Cy will also cause a positive moment, right? It will cause a positive moment about the x-axis, right? So this is going to be equal to, again, plus cy times the lever arm, which is 0.4. Do we have anything else? Equal to 0. So this is what we have, but we found what cy is, so we can find bz. So let's replace cy there. Let's do the replacement. So once we do so, then we'll find that our bz will be equal to we have a 600 by 1.2 plus what is our cy? Our cy is equal to, again here, be careful the way you are going to replace this value. All right. Of course, here we are assuming it is positive, but what we found is a negative value. All right. So you have to feed it the way it is. All right. You have to feed it the way it is there. Okay. Because it means if it went the other side, then it's going to cause, if it went the other side, because where it is right now is causing a moment in the positive direction. But if it went the other side, on the other side, then it's going to cause a negative moment. So feed it the way it is. Feed it the way it is with this sign. All right. It's very, very vital there. Okay. So that is going to be equal to, that's 600 by 1.2. And then we have minus 400 times 0.4. So this gives us bz is equal to minus 560 newtons. Okay, no, sorry, not 560. It's dividing by 0.6. Sorry, divided by 0.6. So this is equal to minus 933.33 newtons. I come again, 600 by 1.2. There is a minus 400 by 0.4 divided by 0.6. Yeah. So we have a minus 933.33, which is our BZ. Then we have summation of moments about the y-axis equal to 0. About the y-axis, AZ do not participate, AX do not participate, BZ do not participate, BX do not participate, 400 do not participate. The only one that will participate is 600 and CX. All right, 600, again using the right hand thumb rule, 600 will cause a negative moment using the thumb rule. So right hand thumb rule, so we have minus 600 times the lever arm, which is 0.6. This is summation of moments about the y-axis. And also CX, also it will cause a minus moment by the lever arm, which is 0.4. Okay, 0.4. What else? That is about it, equal to 0. Therefore, our CX is just going to be equal to minus 600 times 0.6 divided by 0.4. So minus 900 newtons. Okay. So found our CX, and then we have finally summation of moments about the z-axis. Z-axis, which forces are going to participate? We have CX, we have CY, and we have BX. Okay, so these are going to participate. CX is causing a negative moment. So we'll have minus CX times the lever arm. As the lever arm is a 1.2, we are finding moments about the z-axis. And then CY is causing a positive moment. So it's CY times 0.6. Okay, and then we have BX is causing a negative moment, which is BX by 0.6. What else? So CX, CY, BX, that's about it, right? Equal to 0. So we have Cx. Do we have Bx? Not at all. So we need to solve this simultaneously. We have Cy. Okay, we have Cx and Cy, both of them. So our Cx, we found Cx equal to minus 900. Feed them the way they are. We found Cy equal to minus 400. All right. So if we are to feed them in there, then we'll find that our Bx will be equal to, what is our Bx? So minus minus becomes positive. Positive 900 by 1.2 minus 400 by 0.6, okay, divided by 0.6. So Bx is equal to 1400 newtons. I come again, so 900 by 1.2 minus 400 by 0.6 equals divided by 0.614. Right. So what have we remained with? We found Bz, we found Cy, we found Cx, we found Bx. We need Ax. We need Ax. We also need Cx, right? No, Cx is found already. Bx we found, so we can find Ax, and we also need Az, right? Az is not yet found. Great. So then let's get one equation. Let's get this equation. Let's find Az. So we'll get this equation. We'll bring it down. Or just here, we can solve it just here where it is. We just put some dotted there, the full colony. Then we'll say Bz is equal to, what is Bz? We found Bz is equal to minus 933.33 minus, okay? Therefore, Az is just going to be equal to minus 933.33 plus 600. Az is equal to 333.33 newtons. All right, what else? This one here, let me just rub this part where we have solution. So here we have Bx, we already found it. What is our Bx? Our Bx is 1400, and then our Cx is minus 900. Therefore, let's find what Ax is. Ax is just going to be equal to 1400 minus 900. Then this gives us Ax equal to minus 500 newtons. So let's write these values. What is Az? Let's check for Az. Az is in the same direction, so this is equal to 333.33 newtons. Great. What is Ax? I mean Az, that was Az. What is Ax? Ax is minus 500, so the direction changes. So let's change the direction. Direction will be going in instead, like so. And what's the value of this Ax? This Ax, let's write it somewhere there. This value is just equal to 500 newtons. All right, what is Bz? Bz is direction changes. So let's rub this arrow there. We indicate the right direction, and we found Bz equal to 933.33 newtons. What is Bx? What is Bx? Bx is 1400. It's in the correct direction. It's 1400, like so. All right. What is Cy? Cy direction changes. The direction changes is in this direction, like so. and this is equal to Cy is equal to 400 newtons. And what is finally Cx? Cx is minus 900, so the direction changes. So arrow will go like so, and then this is just going to be equal to Cx. We said this is equal to 900 newtons. All right, let's just give it a quick check. In the x direction, we have 1400 positive, then negative 1400. Yeah. In the y, we have 400. Okay, 400. Okay. In the z, we have 933 negative, then positive, we have 600, and the 333, which is a 933. Great. So everything seems fine. Let's just now outline these solutions. Great. So we have AX there. We have CY there. Okay. And then we have AZ there. And then we have BZ there. All right. And then we have CX there. Okay. And then we have BX there. Okay. So we have 6 of them. 1, 2, 3, 4, 5, 6. Great. I think this is really about it. And we are done. And I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screen.